Hello, today's topic is roots of a quadratic equation with real coefficients. An equation of the form ax squared plus bx plus c, where a is not equals to 0 and abc belongs to R, is called a quadratic equation with real coefficients. C is belongs to R is called a quadratic equation with real coefficients. The quantity d is equals to b square minus 4ac is known as the discriminant of the quadratic equation. Discriminant. Okay, and the roots of this quadratic equation are defined by alpha and beta, where alpha is equals to minus b plus root over b square minus 4ac divided by 2a, and beta is equals to minus b minus root over b square minus 4ac divided by 2a. Okay, now let me take another color here. Okay, the nature of the roots is like this. The roots are real and distinct if and only if d is positive. if d is positive, then the roots are real and distinct. If and only if d is equals to 0, the roots are real and equal. Okay, the roots are complex with the non-zero imaginary part if and only if d is less than 0. Non-zero imaginary part if and only if d is negative. The roots are rational if and only if a, b, c are rational and d is a perfect square. Rational if and only if a, b, c are rational and d is a perfect square. Okay, and the roots are of the form p plus root q, p plus root over q, where p and q are belongs to q if and only if a, b, c are rational and d is not a perfect square. The sixth point is, if a is equals to 1 and p comma c is belongs to I, and the roots are rational numbers, then these roots must be integers. And the roots are rational numbers, then these roots must be integers. Okay, and the last one is, if a quadratic equation in X has more than two roots, then it is an identity in X. Has more than two roots, then it is an identity in X that is A is equals to B is equals to C equals to 0. Okay, so you need to remember these 6 points about the roots of a quadratic equation with real coefficients. Now we try to understand with an example. So let's start with the example. Okay, suppose we have a quadratic equation ax square plus bx plus c is equals to 0. Okay, and the roots of the equation are real and distinct. Real and distinct. And we are given 4 options and we need to find the correct one. The first option says that both roots are greater than minus b by 2a. The next option is both roots are less than minus b by 2a. Third point says that one of the roots exceeds minus b by 2a. And the last option says that none of this. Okay, so let's start the solution. The roots of the given equation can be written as alpha minus b minus root over b square minus 4ac divided by 2a, beta is equals to minus b plus root over b square minus 4ac divided by 2a. Since alpha and beta are real and distinct, therefore we can write that b square minus 4ac is greater than 0. It is evident from this figure that a is positive, and this is the graph of or the visualization of the quadratic equation, which is a parabola. The coordinate in here is alpha comma beta, it is beta comma 0, and this is nothing but minus b by 2a comma 0. So from this picture we can say that minus b by 2a is in between beta and alpha. Okay, sorry, this must be beta and here it is alpha. Okay, so one root is less than minus b by 2a and other exceeds minus b by 2a. Therefore, the correct option in here is option C. That is, one of the roots exceeds minus b by 2a. As we can see that one of the roots exceeds minus b by 2a, which is alpha. Okay, so that's all for today. Thank you very much.